Hi everyone, welcome to the 7th video in this series, Primary Keys and Foreign Keys. In this video, we're going to be covering a few topics. So first we'll start off with a recap of tables, and then we'll move on to using multiple tables and why we need multiple tables in databases. And then we'll look at primary keys and foreign keys. So this video will be a little bit theoretical compared to the last few ones. So just as a quick recap, we look at why we use databases. We looked at this in detail in a previous video, but I just want to recap some aspects of it because we'll be referring to these in the rest of the video. So I just want to recap everything. So the main reasons why we use databases: first, they provide efficient storage of data. Second, they provide convenient storage of data, and this is something that will be covered in more detail in later videos. And last, they give us safe multi-user storage of data. Again, this is something that we will come back to in later videos. So for now, the main thing that we're going to focus on is the efficient storage of data. And our two main goals is to make data storage and access as efficient as possible. So that's what we're going to be focusing on in this video. Just a quick recap of tables. You already know that a table is the collection of related data entries, and each table has columns, rows, and a name. So this table is named film, and it has these 5 columns. So this is the kind of table that we will be using in the example for this video. So this is the table that we're going to be using, and this is the data that's been filled in. So you can see that there are 5 different films stored in this table, and they all have a title, a release year, the actors in the film, a whole bunch of data. And you might have noticed that I've highlighted this column, this film ID. So let's think about this ID column for a second. It's a column that we've seen quite often, even in our previous videos. So if I just quickly flip to MySQL, so just to show you, you know that we've been working with the university database in our last few videos. And if I open the tables, you can see that every table has this ID column. So professor ID, students has the student ID, subject has the subject ID. So every table that we've worked with has had the ID column, and this one does as well. So this ID column is very important. It is what we call a primary key. A primary key is the unique identity for each row. So every film in this table has a unique film ID. And that's why the film ID is the primary key. So it uniquely identifies every film that you have stored in the table. And no two films can have the same film ID. Usually, even if you try to assign the same film ID to like 2 films, the database will throw an error and say you can't do that. So most databases actually have that kind of functionality that prevents you from assigning the same primary key to 2 or more rows. So even databases protect against that kind of error. So a primary key uniquely identifies every row in the column, and it makes sure that you can easily access. It makes sure that every row is unique, essentially. So even if the title is the same, the release year is the same, the actors are the same, but the film ID will be unique for every single row. So that is what a primary key does. It identifies every row uniquely within the table. Okay, so this is what we're storing, right? This is the table that we have, the same columns as before. And now let's think back to the goals that we had at the beginning of the video. Is this efficient storage, and is this convenient to access? Those are the 2 questions that we want to answer. Before we think about answering these questions, let's look at what efficient actually means. So by efficient, what we mean in this case is that we don't want to store the same data in multiple rows. Or in other words, we don't want to repeat any of the data. So that's what efficient means for us. So again, going back to our question, is this efficient storage? The answer is no, because you can see that I've already highlighted it here. There's an actor that we're storing multiple times. This actor, Bob Fawcett, is appearing multiple times within this table. And because he's acted in 2 different movies, right? But that's not what we want. We don't want to store his name multiple times just because he's appearing in multiple films. That's not very efficient, because storing takes up memory, and we don't have the amount of data that we store in databases today. You can't afford to store something multiple times and have it take up that kind of storage. We have to make it as efficient as possible. So storing the same thing multiple times it's not efficient. So the answer to this question is no. This is not efficient storage. And if you think about, this is a small table, there are only 5 rows. But if you have even a medium-sized table with 1,000 rows, and you have this kind of data, then it's very possible that you will be wasting a lot of storage by storing the same actor many times in many rows. So if you expand this example to bigger tables and bigger databases, this is just not efficient. So let's think of a solution. What we can do is we will separate the data. So we will have one table called film that stores the film details, and we'll have another table called actor that stores the actor details. And the film ID, it was the primary key for the film table. In the same way, we'll have an actor ID, which is the primary key for the actor table. So again, the primary key uniquely identifies every row in the table. So this actor ID, it's unique for every actor in this table. So no 2 actors will have the same actor ID. And to store information on which actor acted in which film, we'll have this actor ID column. And we'll store just the IDs of the actors that were in the film. So this film, it had 2 actors, 1 and 10. So that was this actor and this one. Film number 2 had actors 2 and 8. So that was this actor and this one. So yeah, that is how you can, cross-reference these 2 tables and see which actor was in which film. Okay, so this was a solution that we came up with to make our storage more efficient. Is this actually efficient? The answer is no, because again, we're storing the same thing multiple times. Instead of the actor's name, it's just the actor ID now. So this actor with the actor ID number 2 is appearing multiple times. Even actor ID number 1 is appearing multiple times. So we haven't made our storage that much more efficient. It's true that we're storing just numbers instead of long character sequences of names, but it's still not as efficient as we want it to be. We're still storing the actor ID multiple times. So this is not a good solution. It doesn't make our data storage that much more efficient. We can do better. Okay, now another solution to make our storage more efficient. So we'll just get rid of the actor ID table. So these are the same tables as what we saw last time, the film table and the actor table. Now what we'll do is we'll get rid of this actor ID table, right? And we will create a new table that stores only the actor ID and the film ID. So this might sound a little confusing, so just bear with me. So this is the new table that we are going to create. We'll call it film actor because it combines the film table and the actor table. And what we'll do is we'll store just the actor ID and the film ID. And the way you can cross-reference this table is, so actor ID 1, this actor was in film 3, this film. And actor ID number 2 was also in film 3, this film. And that actor ID number 2 refers to Nick Wahlberg. So that is how you cross-reference data from this table. you have to refer to the film table and to the actor table to find out your information. But that is okay, because SQL can do that for us, all that cross-referencing. That is something we will get to in the next video. But yeah, for now, this is how you can cross-reference and figure out which actor was in which film, right? And you might think, okay, this is not actually making it that much more efficient, because again, first of all, we've created a new table, and second, we're storing the same actor ID multiple times. So actor ID 2 appears twice, and again, film ID also appears twice. There's 4 appearing twice, film ID 3 appearing twice. So how is this any more efficient? It's efficient because the combination of actor ID and film ID is unique for every row. So actor ID 1 and film ID 3, this combination will appear only once, and so on and so forth. This combination 6, 1 will appear only once. So film ID and actor ID, they are repeated multiple times in each their columns, and that's okay, because this combination is unique for every row. Okay, so we talked about primary keys before, and I mentioned that the primary key for the film table was this film ID column, and the primary key for the actor table was actor ID. So, and we know that a primary key's main function is to uniquely identify every row in the table, right? So let's think about what the primary key for the film actor table would be. I also said that this combination of film ID and actor ID, the combination of the two columns, is unique for every row. So 1, 3 is unique. It doesn't appear anywhere else. 6, 1 is unique. It doesn't appear anywhere else. So the primary key for this table would be the combination of film ID and actor ID. So primary keys don't have to be just a single column. They can also be multiple columns, as long as they just uniquely identify every row in the table. So film actor has its primary key is actor ID, film ID, that combination. And film ID is the primary key for the film table. Actor ID is the primary key for the actor table. So this can get a little bit confusing, and we'll go through the next few parts a bit more slowly so that you can get used to the idea of primary keys. Okay, but real quick, just before that, this is the newest solution that we had. That was to create a film actor table that stores the combination of actor ID and film ID. So let's think about our goal and whether this solution meets that goal. Is this efficient? The answer is yes. Even though you've created a new table, you are making sure that you're not storing the same data multiple times, because this combination is unique for every row. So the combination of actor ID and film ID appears only once within the table. So yes, this is efficient storage of data. We're not storing anything multiple times in the same row. And for every row that we have, each row contains 100% unique information. And this is true for all three tables: the film table, the actor table, and the film actor table. Every row contains 100% unique information, and we're not storing anything twice. So this is efficient. This is a good way to store our data, and this is the way the data is usually stored in databases. Our second goal was whether this is convenient. Was to assess whether this is convenient to access, and also the answer to that is also yes. The thing is, convenience is usually something that is taken care of by what we use to access the data. In our case, it's the programming language SQL, and SQL usually makes it very convenient to access the data. So this is not something that we have to worry about too much, because this is taken care of by the programming languages that we use to access the data. But we've come up with a solution to make our data storage much more efficient, and this is the answer. It's to create a third table that stores the combination of actor ID and film ID. So this brings us to databases. which we've already looked at a little bit before, but now we'll get into the real concept behind databases. So we've already looked at primary keys. We've looked at why we need multiple tables, right? We needed a separate table to store the film, a separate table to store the actor, and a separate table to store the cross information between the two. So that's why we need multiple tables to make data storage more efficient. Now let's quickly recap primary keys. So the primary key for the film table is the film ID column. The primary key for the actor table is the actor ID column. And for the film actor table, the primary key is the combination of film ID and actor ID. Okay, that was primary keys. Now let's move on to something called foreign keys, right? This is the same example as before, but let's look into foreign keys using this example. So this film ID column comes from the film table, right? And the way that it works is that you can look at the film ID and then refer back to the film table and figure out which movie, figure out the name of the movie, right? So film ID 1 refers to this movie, Academy Dinosaur, and actor ID 1 refers to this actor, Penelope Guineas. Right, so that is how you refer to data between tables by using the actor ID and the film ID. So what we can say is that the film ID references the film table, right? So you use the film ID to refer to the film table, and the actor ID references the actor table. So what we can also say is that in this film actor table, the film ID is a foreign key for the film table, because in this table right here, film ID is referring to the film table, and it's this column here. So the film ID column refers to the film table. So the film ID column here is the foreign key for the film table. And similarly, the actor ID column here is the foreign key for the actor table. So that is essentially what foreign keys are. They come from other tables. So the film actor table doesn't have original columns as such, right? It inherits the film ID column from the film table and the actor ID column from the actor table. So they are foreign keys for these two tables, and that's how foreign keys work. They allow you to refer to other tables. Okay, and just make sure that you don't get confused. So the combination of film ID and actor ID, that combination. So both of these columns together, they are that combination is the primary key for the film actor table. But individually, the film ID column on its own is a foreign key, and similarly, the actor ID column on its own is also a foreign key. Okay, let's look at how we can add just one more table into our collection, into our database. So let's add the category for the film. So we have our film table, and now we have a category table. So the category table contains information on the different categories. This is the name of the category, and each category has its own ID. And similarly, the way we store data with the actors, that's how we're also going to store data with the category. We'll create a third table called film category, and that stores the combination, the film ID and the category ID. And just like we saw in the film actor table, this combination is unique for every single row. So this combination of film ID and category ID is the primary key for the film category table. But the individual columns are the foreign keys. So this film ID column is a foreign key, and the category ID column is the foreign key. The film ID column, this film ID column here references the film ID column from the film table. And this category ID column here references the category ID column in this main category table. So let's put it all together so that it makes a bit more sense. We have three individual tables that are were initially unrelated. We had a table that contained information on the films, we had a table that contained information on the actors, and we had a table that contained information on the different categories that we have. And we have two tables that connect the information between them, film actor and film category. So this is the film actor table that combines the info from the film table and the actor table, and the film category table combines the info from the film table and the category table, right? Okay, so this is our database. This is what we have so far. We've got 5 tables, 3 individual tables or sort of main tables, and 2 tables that connect the information between them. So the primary keys for our individual tables, there's the film ID column from the film table, the actor ID column from the actor table, and the category ID column from the category table. So these are the primary keys for these 3 tables. For our combined tables, these we have for the film category table, the film ID, category ID, that combination is the primary key. And similarly for the film actor table, the combination of actor ID and film ID is the primary key for that table. And our foreign keys are the film ID here, which comes from the film table, the actor ID here, which comes from the actor table, and the category ID, which references the category table. So there are multiple keys at work here. There's the primary keys for our individual tables listed here. There's the primary keys for our combined tables, and there's the foreign keys. Okay, so this brings us to the end of this video. It just outlines the main concepts of primary keys and foreign keys and why we need them and why we use them. So take some time to get clear with the concept of primary keys and foreign keys, because initially they can be confusing and it can be difficult to fully understand the relationships between the different tables. So yeah, take some time to understand this concept. But other than that, thank you for watching, and I will see you in the next video.